So let's take a look at class inheritance. And we'll start by considering a motivational example. So some objects are quite similar. And in some sense, it's inevitable that some objects will be similar because we might, when you write a program and you're trying to solve problems, some of the problems you're going to try to solve are going to be similar. Like you might be sorting a list of strings, or you might be sorting a list of integers. You might be representing, a square or a rectangle, so you could draw it on a screen in a GUI or in a game. And so some concepts are just related to each other, and it makes sense their code would then be related to each other. Okay, but when we start, modeling, our concepts as objects, what's going to happen is that the organization of code gets isolated into objects and kind of encapsulated into objects. And then that makes it harder to share code rather than easier because, right, I'm going to stick some function inside one object and then it's not easy to use that function somewhere else. I've written it once, I've made it work, but now it's locked into my rectangle object and maybe it's not easy to reuse somewhere else. And this, at first really appears to violate one of our fundamental goals in C++, which is to be able to reuse code, right? We looked at templates and how they help us reuse code. And that's good. But when we write code once, we want to be able to use it again in many different contexts. And so inheritance kind of comes in to help resolve this problem to some degree. This problem that code gets stuck into objects and then it's hard to reuse it somewhere else. So here's an example of our square and rectangle object, of a square and a rectangle object. So inside my rectangle object, I have a length and a width, and then I have a function called area that'll calculate the area. And now maybe I also need a square object, and in that square object, while I really only need to represent a single side, because all the sides of a square are the same length, I might still have a width and length. And my area function for a square would be the exact same thing. It would be the width times the length. And so I've made two different objects here, and these objects are very similar in what they hold and what they do. But they represent different concepts. A square can only be a square. A rectangle could be a square, but it could be a lot of different shapes, rectangular shapes, right, where the width and length vary independently. So this is kind of an example where clearly the area function is going to work the same way in these two objects, even if my assumptions about the width and length are different in the two objects. It'd be nice if I could express a relationship between these two objects rather than just making two different objects. Right, so some of the things we can see there, the area member function is replicated, even though they do the same thing, literally the same thing. And we could try to solve this by making area a global function, but then it would violate encapsulation, right? Because it wouldn't have access to the private data members. And we'd have to jump through hoops to make that work. So making it a global, just to avoid implementing it twice, seems like maybe a bad idea. Violates abstraction encapsulation. The two objects represent very similar concepts. I mean, in fact, a square is a kind of rectangle. So, I mean, these two ideas are very similar. You might say just get rid of one of the objects. Just get rid of square and only have rectangle. Yeah, you could do that. And because they're so similar in the code I'm showing you, that might seem like the best option here. But there are going to be more cases of objects that are similar to each other, but not so similar you could just replace, reduce it down to just having one. So what can we do? Well, what we can do is use what's called class inheritance to specify a relationship between these two objects. And class inheritance makes the relationship explicit in the code so that the compiler knows there's a relationship and that we're reusing a lot of the code in one object inside another object. And we call it inheritance in order to conjure up this idea of inheritance in people, right? When we have children, children share a lot of our genes. And children, you know, biological children are going to have many of the traits of their parents, or some share some of the traits of their parents. And so it's conjuring up that idea. We're going to inherit, we're going to create a new object by inheriting from another object. And so what this line of code here says is that class square inherits from rectangle. We're going to ignore the public keyword for the time being. We'll come back and talk more about what that means. But this line of code is basically saying class square inherits from class rectangle. You have to have this colon here, and you have to have an access modifier here. It can be public, private, or protected, but we're just going to assume public for the moment. And then the name of the class you're inheriting from. And then after that, standard class declaration. So we have our open brace, a closed brace, and in here we could put whatever it is that square needs that rectangle doesn't already have. Because what this inheritance says is that all the stuff from rectangle should get copied into square, and square should contain those member variables and member functions, a copy of them. So when we look at a declaration like this for a class square, then there's some new terms we're going to need to agree upon. And one term is, what's the thing we're inheriting from, right? We're inheriting from rectangle. We're going to get the code out of rectangle and put it in a new object, square. And so this object we're inheriting from, we typically call a base class, or the base class. And square is the derived class. You might also say that square inherits from rectangle, right? Or square derives from rectangle. Those two statements would be synonymous. And rectangle is the base class, or square is derived from rectangle. Derived classes, this last statement here on my slide, derived classes inherit a copy of all member variables and member functions and can use them within their code. So square gets a copy of everything in rectangle, but then square can also add its own additional features beyond that if it wants to. I didn't do it here just to keep this simple, but you could then define square the way we always have. It's just anything in rectangle you don't need to include because it already has one of those. So here's our new code using inheritance. So we have a rectangle over here on the left that has a width and length. Its constructor takes two integers that it uses to initialize width and length, and then it has this area function. So now when I define square, I just need to say that it inherits from rectangle, right? It derives from rectangle. And then I'll give it a constructor because it needs its own constructor. One of the things it does not inherit actually are the constructors from rectangle. And so if we don't make a square constructor, then the compiler, again, just like before, in the non-inheritance case, the compiler will make a default constructor for us. But we don't want a default constructor. We want to be able to specify what our width is. And so we make a new constructor square that takes a single number because both sides of a square are the same. And then I'm going to talk about the syntax more in a future video, but then we can ask for the rectangle constructor to be called with x as both of its arguments in order to initialize the width and length that are inside the square object that were inherited from rectangle, right? So since rectangle has a constructor, we will just use that constructor to initialize those internal objects. Some important details. Only public members of the base class can be accessed by member functions within the derived class, or at least so far. I'm gonna refine this to include another set of variables, well, under the protected keyword eventually, but for now, we only know about public and private. And so between the two, public members in the base class are accessible in the derived class, but private members in the base class are not accessible in the derived class. So private, things that are private stay private, even to classes that inherit. And we can add new members to the derived class. We're not restricted to only have the things we inherit because that wouldn't be very helpful. Like we just really shouldn't have two objects if we couldn't add more. So we're usually going to add a constructor at least. We may also need to add a destructor. We may need to follow the rule of 3 in that case, right? And we may need to add extra member variables so that we can do more in our derived class than was being done in the base class. But this is the basic idea. The key thing I want you to know so far is that when we have inheritance, what we're really saying is that the derived class is borrowing a lot of the functionality from the base class. And because of that, we don't need to re-implement that base class functionality. We can just use it in the derived class. Now, if I were to draw a picture of what that looks like, then really what we're saying is that literally inside any derived object, there exists a base object. So if this is my rectangle object where I have a width, a length, an area, and a rectangle constructor, then when I make the square object, what it kind of is it's a rectangle first, and then we add on to the rectangle some extra pieces, like the square constructor. And this is really kind of how the object would look to the compiler. That the square object, inside of it, there's a rectangle object, and then in addition to the rectangle object, there's a bunch of other member variables that we've added to make it unique to square. And actually the member variables from rectangle go at the very beginning of the square object. It's like we compress all of the rectangle part to be the very first part of the square object, and then anything extra we add on comes after those pieces. And there's a reason that we do that, and that will become more apparent later. But if you were literally to look in memory, you would see that width and length have to come first. They're going to be the very first members of the square object, and then anything we add comes later. Now, this is different than creating a class and making a member that's a rectangle. It's kind of a subtle difference, but if you just make a member variable that's a rectangle, then you're not really gaining, all the functionality that comes from that base class. And we're going to talk more about that when we talk about the is-a relationship and exactly what it means to have public inheritance versus private inheritance. So for now, I'll just say that it's not the same as putting a rectangle object inside of a square object as a member variable. Though if you draw it as a picture, it looks very much like that. Now, in summary, class inheritance makes relationships between classes explicit and allows for code reuse across classes. And a derived class is said to inherit from a base class. And we'll often talk about derived class versus base class. And then you just need to look at that declaration of the derived class to know which is the derived and which is the base. It makes sense to create a derived class from a base class whenever the derived class needs all or most of the functionality of the base class.